Imagine you have two identical balloons. One is filled with light, nimble hydrogen, the smallest element in the universe. The other is filled with heavy, dense carbon dioxide. If they are exactly the same size, and kept at the same temperature and pressure, which one contains more molecules? Welcome to the Learning Assistant app YouTube channel. The answer to that question is perhaps one of the most elegant surprises in all of chemistry. They contain exactly the same number of molecules. This is the essence of Avogadro's law. To understand why this works, let's look at a container of gas and zoom in until we can see the individual particles. Notice how much empty space there is. In a typical gas, the actual molecules take up less than 0.1% of the total volume. The rest is just nothingness. Picture two different gases side by side. On the left, we have helium, tiny single atoms zipping around. On the right, we have butane, large complex molecules made of 14 atoms linked together. Now, look at what happens when we maintain the same pressure. Because these particles are constantly flying around and colliding with the walls, the pressure they exert depends on how many of them are hitting those walls, not how big they are. Here's the key insight. Because the distance between molecules is so massive compared to the size of the molecules themselves, the personality of the gas disappears. Whether the particle is a tiny dot or a bulky cluster, it effectively occupies the same amount of space in the crowd. Let's visualize this with a simple experiment. Imagine a cylinder with a movable piston on top. Currently is filled with 1 mole of gas. As you can see, it occupies a specific volume. Watch what happens as we pump in another mole of gas. As the number of particles, which we call N, doubles, the volume V must also double to keep the pressure constant. We can express this relationship mathematically as V over N equals a constant. It's a direct, linear relationship. If you have twice the amount of stuff, you need twice the amount of space. But wait, why is this so important? Before Amadeo Avogadro proposed this in 1811, scientists were struggling to weigh atoms. You can't exactly put a single oxygen atom on a scale, but Avogadro gave us a bridge. He showed us that we could count atoms by measuring liters. He realized that volume is essentially a macro-scale ruler for the micro-scale world. So, the next time you see a row of colorful balloons at a party, notice their sizes. If they're all blown up to the same volume, you're looking at an equal count of invisible travelers, regardless of what they are. Avogadro's law reminds us that in the world of gases, it's not who you are that defines the space you take up. It's simply the fact that you exist.